Have you ever wondered if the universe speaks in numbers? Cone, the intricate design of a snowflake, are the universe's way of organizing itself. You might be wondering, what are these patterns and how do they manifest? Today we delve into the fascinating world of mathematics finds concrete expression in the seemingly chaotic world of nature. But is it really chaos that we are observing? Or are we simply not looking close enough to see the patterns hiding in plain sight? Consider this: the spiral pattern of a pine cone, the intricate design of a snowflake, the branching of a tree, the formation of a seashell, and even the arrangement of seeds in a sunflower. All these phenomena on the surface appear random and unconnected. However, dig a little deeper and you will find a common thread, a hidden language, the language of mathematics. These patterns are not mere coincidences, nor are they the result of some cosmic accident. They are, in fact, a fundamental part of the natural world. They are the universe's way of organizing itself, of creating order out of chaos. They are the intricate blueprints, the hidden codes that nature uses to construct, grow, and evolve. These mathematical patterns are found everywhere in nature, from the smallest atomic structures to the largest galaxies, and they provide us with a deeper understanding of the universe and our place within it. The beauty is that these patterns are not just theoretical constructs, but are tangible and observable. Now, you might be wondering, what are these patterns and how do they manifest in nature? Well, we have a few exciting examples to share. The Fibonacci sequence, a simple numerical series that has been found in everything from the spiral arrangement of leaves on a plant to the spiral galaxies in the universe. The golden ratio, a mathematical constant that seems to be a universal standard for beauty and aesthetics in nature. And then there are the Platonic solids, geometrical shapes that form the building blocks of our universe. Today we delve into the fascinating world of nature's mathematics, exploring the Fibonacci sequence, the golden ratio, and Platonic solids. Imagine a sequence of numbers where each number is the to ancient Indian mathematics. Today, it's just a mathematical curiosity. It's a fundamental sum of the two previous terms. It's a real, tangible pattern that and continues indefinitely, each number a sum of the two before it. The Fibonacci sequence is named after Leonardo of Pisa, also known as Fibonacci, a 13th century Italian mathematician. But its roots reach back even further, to ancient Indian mathematics. Today, it holds a special place in our understanding of the mathematical patterns in the universe. So, how does this sequence unfold? Starting from 0 and then 1, each number in the sequence is simply the sum of the two numbers before it. 0 plus 1 gives us 1, 1 plus 1 gives us 2, 1 plus 2 gives us 3, 2 plus 3 gives us 5, and so on ad infinitum. But why is this sequence so important? Well, it's not just a mathematical curiosity, it's a fundamental aspect of many natural phenomena. From the branching of trees, to the arrangement of seeds in a sunflower, to the spiral of a galaxy, the Fibonacci sequence emerges time and again as nature's counting system. The Fibonacci sequence is a form of what mathematicians call a recursive sequence. This means that each term in the sequence is a function of previous terms. In the case of the Fibonacci sequence, each term is the sum of the two previous terms. This simple rule generates a sequence that appears to have a kind of built-in growth factor, mirroring the growth patterns we see in the natural world. But this sequence isn't just about numbers, it's also about aesthetics. The proportions between Fibonacci numbers approximate the golden ratio, a mathematical constant often associated with beauty and harmony in art and nature. The Fibonacci sequence isn't just a fascinating numerical phenomenon, it's a real, tangible pattern that appears throughout the natural world. What if there was a mathematical formula that could measure beauty? It's like this: 0, 1, 1, 2, 3, 5. Of a nautilus shell to the arrangement of leaves on a bough. It's as if our minds instinctively recognize to be a universal standard for beauty. In Greeks. It's a simple ratio, roughly equal to 1.618, that emerges from the Fibonacci sequence, a series of numbers in which each number is the sum of the two preceding ones. The Fibonacci sequence starts like this: 0, 1, 1, 2, 3, 5, 8, 13, and so on. If you take any two successive numbers in this sequence and divide the larger one by the smaller, the result approximates the golden ratio. Now, what does all this number talk have to do with beauty? Well, it turns out that the golden ratio is all around us, creating proportions that our brains find inherently pleasing. From the layout of ancient Greek temples to the shape of the most admired artworks, from the structure of a nautilus shell to the arrangement of leaves on a plant stem, the golden ratio is there, silently shaping the world in ways we seldom notice. But it's not just about architecture or art. The golden ratio also applies to the human body. Research has shown that facial features arranged according to the golden ratio are typically perceived as more attractive. This is because our brains are seemingly hardwired to prefer shapes and patterns that follow this ratio. It's as if our minds instinctively recognize the inherent harmony of this mathematical relationship. So, the next time you marvel at a stunning sunset, the intricate pattern of a snowflake, or the symmetry of a beautiful face, remember, you're not just appreciating nature's handiwork, you're also witnessing the power of the golden ratio, a mathematical principle that, for reasons we still don't fully understand, seems to be a universal standard for beauty. The golden ratio isn't just a mathematical curiosity, it's the secret behind some of the most beautiful sights in nature. Ever thought about the shapes that form the building block, the cube, the octahedron, the dodecahedron, with 20 triangular faces, is the most other mathematical phenomena that we see in nature. The hydra that are the cornerstone of geometric beauty in our universe. These shapes are defined by their perfect symmetry. Each face, each edge, and each angle within a Platonic solid is identical to the others. There are only 5 of these perfectly symmetrical three-dimensional shapes: the tetrahedron, the cube, the octahedron, the dodecahedron, and the icosahedron. Let's take a closer look at these fascinating shapes. The tetrahedron, with 4 faces, is the simplest of the Platonic solids. It's like a pyramid with a triangular base. The cube is the one we are most familiar with. 6 square faces, all at right angles to each other. The octahedron has 8 triangular faces, while the dodecahedron has 12 pentagonal faces. The icosahedron, with 20 triangular faces, is the most complex of the Platonic solids. But how do these shapes relate to nature? Well, they are everywhere if you know where to look. For instance, the cube is seen in the structure of salt crystals. The tetrahedron is a basic structure in molecular chemistry. The dodecahedron and icosahedron are found in the structures of many viruses. Platonic solids also have a deep connection with the Fibonacci sequence and the golden ratio, 2 other mathematical phenomena that we see in nature. They are all part of the same mathematical symphony that underlies the structure of the natural world. So the next time you marvel at the beauty of a snowflake, remember the intricate geometry that shapes its form. Or when you gaze at a crystal, think about the Platonic solid that lies at the heart of its structure. Platonic solids are more than just mathematical concepts. They are the geometric foundation of the natural world. From the spiral of a galaxy to the swirl of a sea, nature uses over and over again. The Fibonacci follow this pattern. The branches of trees also obey the proportion of our forearm to our hand. The Ardo of Pisa, also known as Fibonacci, is a series of numbers where each number is the sum of the 2 preceding ones. It begins with 0 and 1 and continues on infinitely. But why is this sequence so important? Because it's not just a series of numbers, it's a pattern that nature uses over and over again. The Fibonacci sequence is a blueprint, a code, if you will, that shapes the world around us in surprising ways. Consider the petals of a flower. Have you ever wondered why some flowers have 3 petals, others 5, or even 21? It's not a random choice. These numbers are all part of the Fibonacci sequence. This pattern ensures the optimal distribution of petals, allowing every petal to get the maximum exposure to sunlight and rain. It's not just flowers that follow this pattern. The branches of trees also obey the Fibonacci sequence. Each branch grows at an angle to the one before it, following the sequence, ensuring that each new branch has the maximum amount of space to grow and catch sunlight. And what about the swirl of a seashell? That's Fibonacci too. The nautilus shell grows in a spiral that follows the sequence, allowing the creature to grow without ever needing to change its shape. Even our own bodies exhibit the Fibonacci sequence. The proportion of our forearm to our hand, the arrangement of our fingers, the spirals of our ears, and the shape of our DNA, all follow this mathematical pattern. The Fibonacci sequence, this simple series of numbers, is a fundamental principle of the universe. It's in the stars above us, the plants around us, and even in us. It's a testament to the mathematical beauty of the world we live in. Next time you're out in nature, try to spot the Fibonacci sequence. You'll be surprised at how often it shows up. From the shape of a hurricane to the spiral of a sunflower, a number of counterclockwise spirals are usually consecutive in the animal kingdom, in the proportions of a knot of chaos, of making sense out of the seemingly random that seems to pop up in the most unexpected places in the natural world. Let's take sunflowers, for instance. Have you ever noticed the mesmerizing spirals in the head of a sunflower? If you start counting these spirals, you'll find that the number of clockwise spirals and the number of counterclockwise spirals are usually consecutive Fibonacci numbers. And the ratio between these two numbers? You guessed it, it's the golden ratio. And it's not just sunflowers. The same pattern can be observed in pine cones, pineapples, and a myriad of other plants. In fact, this pattern is so prevalent in the plant kingdom that it has been called phyllotaxis, which is just a fancy word for leaf arrangement. But the golden ratio doesn't stop at plants. It can also be found in the animal kingdom, in the proportions of a nautilus shell, for example. And if we look at the larger scale of things, even hurricanes and galaxies show this swirling spiral shape that is characteristic of the golden ratio. The reason? It's all about efficiency. The golden ratio allows for the most efficient packing and distribution, whether it's seeds in a sunflower or stars in a galaxy. In essence, the golden ratio is nature's way of creating order out of chaos, of making sense out of the seemingly random. It's a testament to the hidden mathematical beauty of our universe, a beauty that is as complex as it is simple, as abstract as it is concrete, and as elusive as it is omnipresent. So the next time you see a sunflower, remember, it's not just a flower, but a mathematical marvel. From the structure of crystals to the shape of viruses, polygon, and the same number of faces meet at every apse. Next, consider viruses. It's the microscopic world. The dodecahedron was, remember, you're witnessing the magic of geometry, a man-made concept imposed on nature, but rather nature itself expressing its own inherent order. Consider, for example, the Platonic solids. These are the only 5 shapes in 3-dimensional space where every face is the same regular polygon and the same number of faces meet at every vertex. Named after the ancient Greek philosopher Plato, these shapes are the tetrahedron, cube, octahedron, dodecahedron, and icosahedron. So where do we see these in nature? Well, let's start with crystals. Certain types of crystals, such as those of pyrite, naturally form into the shape of a cube. The process of crystallization itself is a fascinating dance of atoms coming together to form these perfect geometrical shapes. Next, consider viruses. In order to maximize efficiency and ensure survival, many viruses adopt the shape of an icosahedron. This allows them to pack their genetic material in a compact, sturdy structure, ready to withstand the challenges of their environment. Then there are molecular structures. The carbon atoms in a diamond, for instance, link together to form a repeating pattern of tetrahedrons. This gives diamond its incredible strength and hardness. And it's not just the microscopic world. The dodecahedron, with its 12 pentagonal faces, can be seen in the shape of certain types of radiolaria, tiny, single-celled organisms that float in the ocean. These are just some examples of how nature uses the principles of geometry to create form and function. It's as if nature is a master sculptor, using the Platonic solids as its tools. So next time you marvel at the beauty of a crystal or wonder at the complexity of a virus, remember, you're witnessing the magic of geometry at work. Nature is not just chaos and randomness, it's a symphony of shapes, all playing together in perfect harmony. Nature is not just a collection of random shapes and patterns. Flower, seed, spiral, pine cone, scale, stack, a nautilus shell. And finally, the geometry of viruses. These mathematics walking in nature. You're stepping into a world of rhythm. It's a simple series of numbers where each number is the sum of the previous two. It starts with 0 and 1, then continues 1, 2, 3, 5, 8, and so on. This rhythm is not confined to a mathematician's notebook. It's the beat to which sunflower seeds spiral, pine cone scales stack, and galaxies whirl. Then we have the melody, the golden ratio, often represented by the Greek letter phi. It's an irrational number, approximately 1.618, that describes the perfectly symmetrical relationship between two proportions. This melody is not only pleasing to the human eye, but it's also the chords struck in the arrangement of leaves on a stem, the branching of trees, and the spiral of a nautilus shell. And finally, the harmonies are the Platonic solids. These are the 5 regular convex polyhedra, the tetrahedron, the cube, the octahedron, the dodecahedron, and the icosahedron. Each of them is a symphony of geometry, with each face being the same regular polygon, and the same number of faces meeting at each vertex. These harmonies reverberate in the structure of molecules, the symmetry of crystals, and even the geometry of viruses. These mathematical patterns, the Fibonacci sequence, the golden ratio, and the Platonic solids, are the notes, chords, and harmonies of the universe. They are fundamental, ubiquitous, and integral to understanding the natural world. They show us that nature is not haphazard or random. It's a perfectly tuned orchestra playing a symphony of mathematics. So, the next time you step outside, remember, you're not just walking in nature. You're stepping into a world of mathematics hidden in plain sight.